Hello, my name is Emily Barker and welcome to the presentation titled Could We Have Seen It Coming Towards an Early Warning System for Asylum Applications in the EU? This is joint work with Jakub and we are both from the University of Southampton. This work has kindly received funding from QuantMig and Future Res Horizon Europe programmes. So we'll have a short background to early warning systems in the area of migration. So early warning systems had long since been used in different disciplines, particularly macroeconomics. The idea behind an early warning system is to give policymakers advance notice of the crisis or crises. In this typical macroeconomic case, these are for recessions, with the idea that at different horizons, warnings can be given to allow policymakers to put into practice potential solutions to stop or most probably just reduce the seriousness of the crisis. This is based upon learning from previous data and previous crises. This applied model uses similar methodologies. Migration in and of itself is an important topic, but dealing with a perceived crisis is critical to make preparations for. Two recent migration crises is the refugee crisis of 2015 to 2016, with the origins of countries largely associated with Syria but other war-torn countries too. The second crisis was a result of the war in Ukraine following the Russian invasion in February 2022, which was the largest movement in Europe since the Second World War. The existing literature in this area is surprisingly low. The two papers close to the research use different approaches to our paper. The second paper listed here is closest to ours in that they use a large range of big data. It is interesting and important to study potential early warning system models because both of these events have seen more than 1 million arrive in 1 year, which is large and an inflow for a bloc the size of the EU. Any signals to help policymakers make preparations surely helpful. How do we approach this? Well, firstly, we need to look at what a crisis is and consider what data to use to give indicators, as well as what we use to define a crisis. I mentioned previously that we use two case studies. What is often forgotten is the events in Ukraine in 2014, as well as 2015 and ultimately 2022. This first one is around the time of the annexation of Crimea by Russia, which followed the Euromaidan protests. And what about forecasting? The main approach named in this model, they were trying to ultimately have a 6-month horizon offset to give policymakers a warning so they can release funding for resources to deal with this impending crisis. One of the main contributions of this paper is the vast array of data used to produce the models. At the start of the estimation procedure, we had over 1,400 variables for Syria and nearly 4,000 for the Ukraine case study. The Asylum methodologies reduce these to a much more manageable selection in the region of 5 to 25. We also at the end provide a 6-month extra forecast on the end of the sample to look at what would happen in 2023. The main data sources that we use are a number of asylum applications to define a crisis, GDEL, which is a vast geopolitical data resource, Google Trends, so that's just Google searches, and US trade flows. Now you might ask, why are we using US trade flows rather than those in the EU? Well, it's because it's consistent and it is actually available for every country. So for instance, Eurostat will report trade with Ukraine, which, okay, that's fine. But when you look at, for example, Syria, they are only in this block of Asia and Middle East, North Africa countries. So you haven't got that specific. Whereas with this US, you have got that exact specific country. And quite often, any restrictions that are placed on a country by the US are also done by the EU. And then we also have exchange rates and inflation rates. So they can reflect what is happening in a country. So, for example, Syria, they had massive reevaluations of the exchange rate, and then also Ukraine, which is still quite reporting to and having these with for example, the IMF and the World Bank. The methodology we used is to create a binary variable for whether there is a crisis. Ultimately, defining a crisis is a tough task because there are such change in flows between the beginning of the sample in 2008 and 2009 and the first crises for those countries. Nevertheless, we set a variable whether a crisis occurs based on current period growth rates in the last 12 months, a rolling 12-month standard deviation, and an arbitrary minimum value, which presents early extremes in the sample process. So this is 300 for Syria and 60 for Ukraine. Ultimately, we want a model that has its best learning ability and not affected by such small numbers. Now we have this binary variable, we then put it into the estimation. There are 4 possible outcomes. Correctly predicted periods all depend upon the threshold levels, which is model specific and produced in the estimation. There are 3 different levels with noise signal ratio the tightest. The model isn't always right, so there are 2 types of errors. The first is a type 1 error, where a crisis is predicted, but there isn't actually a crisis. A type 2 error is the reverse, so there is a crisis, but there isn't a signal. We use an array of evaluation methods to decide on the relative performance of the models. The first case study we look at is Syria. So what is a crisis? The graph on the left shows the number of asylum applications by Syrian citizens on the left axis, with the horizontal lines defining a standard deviation at the end of the sample in 2021. The standard deviations are at a 0.5, 1, 1.5 and 2. The right-hand axis shows the log transformation number of asylum applications, which is shown in the red line. This isn't so relevant for estimation, but it is helpful graphically to see the extreme changes in application numbers. We include the standard deviation to show that using a constant standard definition as a threshold through a crisis does not reflect a good definition of the crisis. The graphs on the right-hand side are 2 examples of the model that we'll present. The top one shows the 12-month growth rate of the current period of asylum applications, and the lower one with the 6-month growth rate. The idea to show these quickly is when the crisis occurs. So our model is heavy on data. If we look at the graph here, we can see 2 of the variables that we used in the estimation process. So they are specifically the average tone of protest and all political events, which is in red. These are taken from the GDEL database, which is reporting a lot of events that are happening in specific places around the world. So we set this to Syria, and you can see the average tone of reporting. So the higher the number is, the more positive it is, and the lower number it is, the more negative it is. So we can see 2 big decreases in the average tone of the reporting. So the first one is around the time of the Arab Springs, and then the second one is just as the asylum crisis is beginning to start, which you can see is then followed not long after by another increase in the number of asylum applications. So here are 2 of the models that come from our analysis. In total for Syria, we have 6 models. 3 of them are at the current time period, so they're contemporaneous. They are using asylum crisis at time t with the data that is also being reported at that current time period. Whereas the second lot are with this 6-month horizon. So you're using data from essentially 6 months previous with the binary variable today. So you've got that 6-month difference. So you're essentially then able to have this 6-month horizon. So here on the left hand side, we're going back to the contemporaneous ones. We have a definition where a 12-month growth rate of more than 50%, and also at least 1 month in the last 12 months there was another 50% growth rate, and the current number of asylum applications is greater than 2 standard deviation of what's happened in the past 12 months, and that minimum arbitrary value is 300. So when all of those occur, you get a crisis. But in this vector of the explanatory variables, we then have the number of asylum applications, Google Trend searches for asylum, goodbye, reunification, and then we also had 2 more that come from GDEL. So it's listed as ERC, which is event root code, and these are from the GDEL database, which are just defining what type of political event is occurring. So on the graph, we can see how the probabilities are changing. The big black bars are showing the probability at any one time, and at the bottom you can see the yellow ones, which are when there actually is a crisis. These are pretty much perfectly lining up, and there's only a few months in this whole sample where they don't line up. Now on the right hand side we go back to this model, and this time we've got a slightly different definition, a slightly tighter one at least. So you've still got the current period growth rate of 50%. Then you, in the last 12 months, you also have to have one growth rate that is greater than 100%. So you still then had the standard deviations and the arbitrary 300 applications. Within this lecture of the explanatory variables, you still had the Asylum applications. You had Google airport searches of Google Trends, Asylum, German embassy, goodbye, reunification, and then you're back to these event route codes, which are similar to before, but we've got the count of them, the average tone, and we've got them at different horizons. So as well as just looking at the current T, we look at the differences of between 1 and 12 months, and then also lag it as well. Again, we've got the probabilities of the each month crisis, and then also we have the horizontal lines, which are the different levels of thresholds that it has to exceed. So you've got ones that are quite or relatively loose, and then ones that are tighter. So you've still got the main crises that you think of back to 2012, which actually is when they start going. You start getting all these triggers, but then also more recent ones. So we had the COVID lockdown, which is when you can see the red eye, it just dips. So there was a massive drop in them, but then ever since, particularly mid-2021, it started increasing again, and we've got some crises. So now we're looking at when there were false predictions made. So on these graphs, when there is a positive bar, it's when there were false positives, and negative bars are when there were false negatives. So we report this for each of the three models that are estimated, both the contemporaneous and the T6 models. So it's quite interesting to see when these false predictions were made. Now, when they are in that crisis period, especially for the 2012 to 2016, they aren't that much of a concern, because there are so many things going on, and it would be clear to a policymaker or anyone that was working at the time that there's something to go on. So if it was a lot of then, there's no crisis, then you'd be able to think, oh, okay, there is maybe a change in this. But because it's month after month they come back and there is still a crisis defined, then you know that they're just an oddity and something might not be in the data, particularly the binary definition. So what you're then able to look at across the sample is when these are. I mean, it is a question, when should a binary, or when is the number of applications so high that it doesn't need to be a crisis, versus the other way, if it's still a high number of asylum applications, isn't it still a crisis? You can look at it both ways, but it is more important, we think, for a crisis to be defined when there is a sudden growth rate rather than just a constant high number of applications, because you're already dealing with that. It's only if there's going to be a sudden shock in the number of increases. So now we've covered the Syria model, let's look at Ukraine. So on the left we've got the same style graph that we had with Syria. So the red line is the log transformation, and the black line is just the number of the asylum applications. So the horizontal line is actually just defining when the Euromaidan protests were. So you can see how immediately after that there's the whole annexation of Crimea, and the number of the asylum applications significantly increased. We don't include what happened in 2022 simply because it goes off the scale and makes everything else, you can't see it. But you know that it happened. And then on the right hand side again we had two examples of when the crises were, or the results of them. There is a lot of noise before 2014, but we'll come on to talk later about why we have to have that in it. So let's move on. So Ukraine, we're back to the GDALT database to show what happened in Ukraine. So on the left-hand graph, we've got the number of protests, and then on the right-hand one, we've got the number of political events in Ukraine. So you can see the spikes that happened in both 2014 and also more recently the 2021 and 2022, how it's following through. There are also some other ones in between, but these are the two main jumps, which these then you can see that it will follow through to the asylum applications. So here we have two models. On the left hand side we've got the contemporaneous model again, and then on the right hand side we've got the model with a 6-month horizon. On both graphs you can see the yellow gold bars below, which identify when the crises actually were. Now you've got a lot of crises that you think, oh, why are they happening before 2014? Well, that's actually because if we don't have any crises before then, if the first crisis is 2014, then the model is so tight that it's not actually learning anything. So yes, we might not define it as a crisis, but when there were that small number of, oh yeah, you suddenly increase, then the model is able to learn stuff, but it's still got that growth rate, so we're able to see and make the model learn. So in the vector of the explanatory variables, this time we've got asylum applications, and then we've got the US exports, US exports to Russia, and then also the imports at different lags, and then the Google Trends asylum, which the searches are in Russian, but they are done in Ukraine, so we know that Russian is still a common language, particularly in the eastern regions of Ukraine. So we had to search in Russian and in Ukraine. And then you also had the number of protests that are in Ukraine. Whereas on the 6-month horizon one, we had searches, we had the figures, so the Ukraine asylum applications, exports to Russia from the US imports from Russia, the Russian real exchange rate, the asylum applications, or rather Google Trends asylum in Russian, asylum in Ukrainian. Then you've also got Google Trends for Europe in Ukrainian and Russia. Then you have one for Krakow, Poland, which we use as, okay, that's where they're going, because that was one of the first cities that the Ukrainians got to. Then we're back to protests in Ukraine, a count and a protest intensity. So now we're looking at the false predictions that were made in Ukraine. Again, we've got the, if it's above 0, it's a false positive, and if below, false negative. So on the right hand side, we've got the contemporaneous models. Now we actually only do 2 of these because of the 8 that we essentially tried and went through with the Lasso process. Only 2 of them made any sense that was any worth reporting. There are still 3 for the 6-month horizon, so that is because there were vectors that came back that were useful to report in this at least. So again, with the 6-month horizon, we see quite a few more errors with this, particularly in that before 2014 sample. But when you get to after 2014, or that significant increase in first asylum applications, there are many fewer false predictions. Whereas in the current time period, there aren't as many false predictions afterwards or before, but again we've spoken about how those come in. So to conclude, our paper has shown that large changes in asylum applications can be forecasted with 6-month horizons. The drivers and indicators differ across countries, so yes, we've had 2 very different countries here. We've had Syria, who were going on a civil war for years, and then we had Ukraine, which we know quite a lot more about with its relationship with Russia. So we had 2 different ways to look at that. You had Syria, which was, you could very much isolate all the political protests, whereas Ukraine had this one main outside aggressor in Russia. So these were 2 extreme differences, and we've learned that big data is important in forecasting these changes of asylum applications, which also include these geopolitical and macroeconomic data, which particularly for demographers, macroeconomics might not be so obvious, but it's one of these data sources that you can actually report on a high level of frequency. One thing to note is the magnitude of the crisis is not fully captured. So the model will tell you if there is a high probability, which is somewhat related to the flows, but that last bit of information really does need to be taken from the human or researcher that's reading the model and putting that last bit in. There is a limit with every model, and that is so that you need someone to add a human interpretation. We can't put this all down to AI yet, but we have shown that there is a bit more control when you're looking at, oh, is there a crisis versus isn't there, than if you were just completely looking at a asylum application forecasted. So when you're only doing between 0 and 1, it's a bit more much manageable. Between one where you can have, say 1,000 in a month, and then it's worse, it was 60 odd 70,000 peaking for Syria, so, or in Ukraine, 2 million. So yeah, we can go with that and just see how we can work to it in the future and improve our models. Thank you for listening.